find the inverse of a function. Our objective, same thing. We want to find the inverse of a given function. So what do we know? We know the definition of an inverse function. You have an inverse function when f inverse of x is equal to x, and f inverse of f of x is equal to x. And the domain of f is equal to the range of f inverse and vice versa. So the domain and ranges get switched. Okay, let's come up here a little bit. As above, the definition of an inverse of a function tells us that the domain of f is equal to the range of f inverse and vice versa, right here. Okay, the x's and the y's switch places. Looks like I have a period right there. Okay, we can use this fact to find the inverse of a given function by switching the x and the y's. Okay, we'll see how that's going to work in just a moment. Okay, so how to find the inverse? It's called switch and solve. First thing you want to do, and it makes it a little simpler, it's not necessary, but it makes it a bit simpler, is replace the f of x with the y. It just makes the math a bit easier to work with. Number two, we're going to interchange, or we're going to switch, here's the switch part, x and y. Step three, we're then going to solve for y. And then step four, we're going to replace the y with f inverse of x to find, and that'll give us the inverse. Okay, sounds like, doesn't sound too bad to us. Let's take a look. So find the inverse of f of x equals 7x minus 5. What function will undo this function? Well, step one, let's replace the f of x with a y. It just makes it a little bit easier to follow the math. So there you have it, step one. Step two, switch x and y. Okay, everywhere you see an x, put a y. Everywhere you see a y, put an x. So this, step two, this y becomes an x, and this x becomes a y. So there's your switch x and y. Okay, step three, switch and solve strategy, solve for y. We got to solve for y now. So add 5 to both sides. 7y equals x plus 5. Added 5 to both sides and just rewrote it with the y on the left. Then I'll divide both sides by 7 and have y is equal to x plus 5 divided by 7. Okay, so this was the solve for y. I have solved for y. Step 4, replace the y with f inverse of x. Whoops, I forgot. This is step 3 right down here. Step 4, replace the y with f inverse of x with a little raised -1 right there is equal to x plus 5 over 7. This function is the inverse of this function and vice versa. This function is the inverse of this function. So that's it. These 4 steps really only requires, you're replacing those 2 pieces. That's fairly simple. A switch and then a solve, a switch and solve strategy. Let us do another couple of examples. Just a second here, I'll get my stuff together. Okay, so let's find the inverse of f of x is equal to x cubed plus 1. Okay, so step 1, let's replace the f of x with a y. It just makes moving variables a little bit easier. Okay, step 2, we want to switch the x's and the y. So this y becomes an x, and this x becomes a y, and we're here. Okay, step 3, we're going to solve for y. So I'll subtract 1 from both sides. Y cubed equals x minus 1. I then need to cube root both sides. That's a cube right there, a 3. And I have y is equal to the cube root of x minus 1. So that's step 3, solve for y. And then step 4, replace the y with f inverse. because we know we have found the inverse. So f inverse of x is the cube root of the difference x minus 1. There you have it. Let's do one more example with a couple of x's involved. A little bit more algebra here, but we'll be just fine. Okay, find the inverse of f of x is equal to x plus 2 divided by x minus 3. And we want to note that because 3 will make the denominator 0 and therefore undefined, x does not equal 3. So we can do this. Okay, so x is not going to be 3, otherwise we'd have a problem here. So step 1, let's replace the f of x with a y to make our movement of letters a little easier. So y is equal to x plus 2 over x minus 3. Step 2, let's switch the x's and the y's. We only need to replace, I only have one y to replace with an x, but I have two x's to replace with y's. So y plus 2 over y minus 3. Little more complicated to solve this one, but not a problem. Okay, now let's solve for y. Step 3, I'm going to multiply both sides by y minus 3. So x times y minus 3 is equal to x plus 2. That gets rid of this fraction here. I'll do this math. X times y, I'm going to distribute. I distributed this x. Okay, now here's my y. So let's get rid of this minus 3x by moving it to the, whoops, I made a mistake someplace. Right here. Okay, let's start, let me back up a second. I'm looking at my notes and realizing that I made a mistake. Okay, multiply both sides by y minus 3. I'm here, but I'm left with y plus 2 on the right, not x plus 2. I then distribute the x. And I'm here, and that's good. I have y plus 2. Now I need to get my y's together. So I'm going to move my y's to the left. So this is x times y minus y. And I'm going to move my 3x to the right. So this is 3x plus 2. Some algebra here. Now I can factor out the y. Y times x minus 1 is equal to 3x plus 2. And now I can divide both sides by x minus 1. And I just use parentheses because it's here. Keep it the same. And I have y is equal to 3x plus 2. I don't need the parentheses over x minus 1. And this is step 3, solve for y. Took a little bit of doing because I have two y's here and I had to get rid of the fraction. And then I had to get my y's on one side and then factor it out to get one y. And here is the inverse function. Last but not least, step 4, replace the new y, the solve for y, with f inverse of x is equal to 3x plus 2 divided by x minus 1. So the inverse function of x plus 2 over x minus 3 is 3x plus 2 over x minus 1. So again, we're doing the inverses and we're using a switch and solve strategy. Be careful with your algebra.